Okay, so we're going to focus today on, again, solving equations, specifically on the distributive property step. So Unit 2, multi-step, distributive property, and we're on page 29 in our notebook. Okay, so page 29. Multi-step equations. Distributive property. And remember, when I think of distributive property, I think of asking a student to hand papers out. I think of when you go to a party, it would be appropriate that you introduce yourself to all the hosts. So if you have something outside of a grouping symbol, it has to be introduced or multiplied by each member inside the grouping symbol. That is one example of distributive property. Okay? Another example, less seen, is if we have B plus C over A. Okay, A is essentially equal to B over A plus C over A. In other words, everything in the top part of the fraction is being divided by that same denominator. So we have to do distributive division in that sense. But we're going to find out how to kind of eliminate this division to not have as many fractions when we're solving problems that start out that way. So let's go ahead and look at our example problems for today. So number 1 is 5m plus 2 times the sum of m plus 1 equals 23. So looking, I can see that I have grouping symbols, so I need to do the distribute property. So 5m is an individual term, that's going to stay as is. 2 is what I need to distribute to everything within the grouping symbol. So I'm going to wind up with 2 times m and 2 times 1. Then I just do the math, right? 2 times m is just 2m, and 2 times 1 is 2. Next step, combine. Put a C here to remind us that we're going to need to combine. So I look at the left side of the equal sign, and I can see I have a 5m and a 2m that are alike. So 5m plus 2m is going to give me 7m. And then I have a fixed number of 2 that's going to come down because there's nothing to combine with it. And on the other side, I just have 23. So one term, no combination happening. Now I'm going to move on to my rewind step. Remember, my ultimate goal is to solve for m. So I need to isolate this term, 7m, which means I need to undo the positive 2. The opposite of a positive 2 is a negative 2. I must do that to both sides, so says my golden rule of algebra. And moving left to right, I didn't do anything to 7m. 2 and negative 2, they eliminate each other to 0, so nothing comes down. And 23 minus 2, or 23 plus negative 2, is going to be a 21. So now I know 7m's equals 21. 7 and m are multiplying. I can use division, but I'm going to use its multiplicative inverse, has the same meaning. So I'm going to multiply both sides by 1 over 7, giving me m equals 21 over 7, and that would simplify to be 3. If I check my work, 5 times 3 plus 2 times 3 plus 1 equals 23. So 5 times 3 is 15. Following the order of operations, 3 plus 1 is 4. 4 times 2 is 8. Equals 23. 15 plus 8, 23 equals 23. True story. I did it correctly. Moving on to our second example, we have 3/2 times x minus 5 equals -6. So if you remember back to when we talked about the inverse operations, under them, we talked about things you needed to be able to recognize, okay? And one of the things we needed to be able to recognize is that terms are only separated by addition and subtraction. So when I look overall at this equation, it may seem like I have more than one term here, but I really don't. While I have two terms kind of inside the parenthesis, because this entire parenthesis is multiplied by 3/2, this is really like one gigantic term. The reason why I bring this up is because I can eliminate that fraction in front. The way I'm going to do that is I'm going to use my golden rule. I'm going to find the greatest common factor of all the decimals, or fraction, I'm sorry. This is the only fraction. So 2, greatest common factor. So I'm going to multiply both sides by 2. Now, if these were individual terms, I'd have to multiply 2 by every single term. But this is a term altogether, so I'm only multiplying 2 by this entire piece one time. And when I do that, 3/2 times 2 over 1, those 2's simplify out because essentially 2 or 2 over 1 is the multiplicative inverse of 2, the denominator. So that cancels out to give me a 3. I still have my x minus 5. And over here, -6 times 2 would be -12. So I've successfully eliminated that fraction rather than distributing that fraction. I could certainly do it. I would get the right answer that way as well. But if I'm not comfortable with fractions, which a lot of you don't seem to be, then I want to eliminate it and make my life a little easier. Now I go ahead and do distributive property again, and I get 3 times x minus 3 times 5 equals -12. 3x minus 15 or plus -15, either way. If you're someone that needs to do that to help you out, go ahead and do it. So I've done my distributive property. Now I need to check. Do I have anything over here that can be combined? No. Variable term, fixed term. Over here, only one term, so nothing can be combined. So now I'm going to a rewind step. I want to isolate this term because it has my variable. So I need to rewind -15. So its inverse is positive 15. So that eliminates out, giving me 3x equals 3. Still rewinding. I want to isolate that. I have to undo multiplication. I use my multiplicative inverse to get x equal to 3 over 3, which would give me x equal to 1. I bet you a lot of you are like, oh my god, that was so much easier when I eliminated the fraction. Of course, your fractionometer kicking into gear. Okay, last example for distributive property for today. So 27 equals 3c minus 3 times 6 minus 2c. We kind of switch things around. We put the individual term on the left side instead of on the right side. It doesn't really matter. Remember, if we use the transitive property, we can literally flip this around and it would have the same meaning. So 27, 3c is by itself. So when I distribute, remember, subtracting 3 is the same thing as adding a -3. So I need to distribute that subtraction or that negative sign when I do the distribution. So I'm going to wind up with plus -3 times 6 plus -3 times -2c. See how here I took that subtraction and kept it with my term as well. So 27 equals 3c. A negative times a positive is going to give me a negative. And a negative times a negative is going to give me a positive. 3 times 2 is 6, and c. Make no mistake though, if I wanted to, I could write this as not plus and negative. I could write it as subtraction. I could write this as subtraction. I'm just doing it as a plus negative so that you guys can clearly see what sign is associated with that term. So I look to my right, I can't do any combining like terms. I look to my left, I have a 3C and a 6C. Those can be combined. So 27, 3 plus 6 is 9, and I'm going to again put plus negative 18. So I was doing my distribution properties here, my combining like terms property here, and now I'm moving on to a rewind step. C is my ultimate goal, so I want to isolate that variable term to start off with, which means I have to eliminate the negative 18. Opposite of a negative is a positive, so I add 18 to both sides. 20, 30, and that's 15 together, so 45 equals 9C. 9 and C are multiplying, so again I use the multiplicative inverse of 9, which is 1 over 9, so we're multiplying both sides by, and I get 45 over 9 equals C. And if I simplify 45 over 9, I get 5. Now, some people always like to have the variable first, so 5 equals C. Using the transitive property, I can write that as C equals 5. Okay, and those are our examples regarding the distributive property. If you need more help with this, please definitely come to office hours. And remember, we did distributive property when we took our notes on properties. But if you're struggling to understand that, office hours later this afternoon. Have a great day.